Hello children, this is the same chapter linear equation in two variable for class 9. This is second part video. In this video, we will discuss how to draw a graph of a linear equation in two variable. We have already did the plotting of different points on a coordinate geometry, on the chapter coordinate geometry. Remember 2 points for plotting the points and making a graph of linear equation in two variable. Every solution of a linear equation represent a point on the line, and the second important point is every point on the line is said to be the solution of the linear equation. Remember, the graph of the linear equation in two variable always forms a straight line. The first most important thing, the standard form of the equation is ax plus by plus c is equals to 0, which we have already discussed in the previous video. Finding different solution also we did. For drawing the graph, we convert the equation either in terms of x or in terms of y. We generate the points, and these points can be plotted on a coordinate plane. Thus, we obtain a straight line. Let us discuss one example. Draw the graph of y equals to 2x minus 5. Here, the equation already in terms of x. We simply substitute the value 1. In place of x, substitute 1. What we will obtain? 2 into 1 minus 5 gives you 2 minus 5, which is minus 3. If you substitute 2, you will get y is equals to 2 into 2 minus 5. 4 minus 5, yes, it is minus 1. Third value, substitute 3. Y is equals to 2 into 3 minus 5. 6 minus 5 gives you 1. Now substitute 4. Y is equals to 2 into 4 minus 5. 8 minus 5 gives you 3. And the last value, 2 into 5 minus 5, 10 minus 5 gives you 5. Here your points are. Two points is sufficient to draw a graph. But to clear all the concept, I am taking here 5 different points. Let us now see. In a coordinate plane, draw a number line. First value is 1 minus 3. For 1, you will get minus 3. Yes, interesting. For 2, you can write down in an ordered pair. You know the solutions we write down in an ordered pair, or all the points on a coordinate plane always represented by an ordered pair. 1 comma minus 3, first value. Second value was 2 comma minus 1. Third value is 3 comma 1. Fourth value is 4 comma 3. And the last value we have taken is 5 comma 5. If you join all points, you will get a straight line. Remember. Next question which we will discuss is the taxi fare in a city is as follows. For the first kilometer, the fare is rupees 8, that is your fixed fare, and for the subsequent distance, it is rupees 5 per kilometer. Taking this distance covered as x kilometer and the total fare as rupees y, write a linear equation for this information and draw its graph. Let us now see your fixed charge is 8. A person wanted to cover a distance x kilometer. So for first kilometer, he has to give rupees 8. So remaining distance is now x minus 1. For the first kilometer, he will going to give rupees 8. Now next is y is equals to first kilometer rate. Now remaining distance x minus 1, which is charged rupees 5. If you solve the equation, you will get y equals to 5x plus 3. If you substitute x to be 0, 5 into 0 plus 3, the value of y will be equals to 3. Here you can see. In the same way, if you substitute x equals to 1, y value will be 8, and for 2, y will be 13. Here is your solution 0, 3, 1, 8 and 2, 13. Plot the respective points on the graph. We will get the first value was 0, 3. The first value, if you remember, that was 0, 3. Substitute, then 2, 1, 8, and for 2 it is 13. If you join all the three, you will get a straight line. Next question is, find the point at which the graph of the linear equation 2x plus 3y is equals to 6 meets the x-axis. So here we have to find out only a point. If you remember, in a previous video, we have already discussed the point lie on x-axis, the point which lie on x-axis will be of form x comma 0. That means the value of y is 0. We simply substitute this value in a given equation. So our given equation is 2x plus 3y is equals to 6. So 2x plus 0 is equals to 6. X is equals to 3. So the required point is 3, 0 because y is already fixed. Next question is, how many linear equations in x and y can be satisfied by x equals to 1 and y equals to 2? Such an interesting question. Satisfied means how many equations are possible whose solution is 1, 2, or how many lines are possible which passes through 1, 2. In this way also you can think, if 1, 2 is a point, then how many lines can be passed through? By simply analytical method you can check that there is infinitely many equations are possible which satisfies these two solutions. Now let us check how. Y minus x, if I'll write down 1, will it satisfy this equation? Yes, of course. 2 minus 1 gives you 1. Can I form an equation x plus y equals to 3? If you write down x equals to 1, y equals to 2, of course it is 3. So yes, this one of this type of equation is also possible. So 2x plus y equals to 4 also possible. X plus 2y is equals to 5. This type of equation also possible. So how many linear equation will be there which satisfies the values x equals to 1 and y equals to 2? There is infinite number of equations. It is same as how many straight line can pass through a single point. So the answer is yes. There is infinitely many number of straight line which pass through a same point. Next question is, draw the graph of the following equation. Y equals to 3, y equals to x and x equals to minus 5. You know, for drawing a graph, we need a table. So let us make a table for the first part of our question, x and y. If x is 1, y equals to 1. If x is 0, y equals to 0. If x is 2, y will also equals to 2. If for 0 it is 0, for 1 it is 1, for 2 it is 2, 3 it is 3. So we will get a straight line. So this is the equation for y equals to x. Check for the second part. I'm drawing a table for second part here. Y equals to 3. There is no value of x. So it is totally independent of x. Whatever value you put for x, the value of y is always 3 because it is fixed. If you mark all these points on the graph 0, 3, here 1, 3, 2, 3, if you take minus 1 also 3, so what you can observe is y is equals to 3 is a line passes through y which is parallel to x axis, and the third point x equals to -5. Here also x is fixed value, so it is totally independent of y. X equals to x and y. X is already fixed, -5, -5, -5. Whatever value you are substituting, by -1, 0, 1, any value, it is always fixed. So x equals to -5 and -1. We'll put first value here. I'm taking different color for showing, and first value will be here. Second value -5, third value -5, 1, and so on. If you carefully observe, this is perpendicular to x-axis and parallel to y-axis. I hope the concept is clear to you. So remember the point. Graph of x equals to y is always passes through the origin. It will always of this type of form. X dash x y, suppose this is y dash, so y is equals to x. The graph of x equals to a, the second graph, this is your x dash x y y dash, it is always parallel to y-axis but perpendicular to x-axis. And the third type of graph, y equals to b, always parallel to x-axis and perpendicular to y-axis. This is your last question. From the given graph, write the linear equation. This is such an important question too. Let us mark each number line. The first, second, third, and let this be marked by fourth. The first line is passing through 6. For whatever value of x, this value of y is fixed. So the equation is clearly y equals to 6. In the previous video, as we have discussed, if a line is parallel to x-axis, the equation will be of form y equals to d. And the second part, the straight line, if you carefully observe, x for x1 y is -1, for x -1 y is 1, for x is -2 y is 2. So we are getting, in a previous video we have seen the equation, the graph of y equals to x always forms a straight line passing through origin. This straight line is also passing through the origin but showing the opposite sign. So clearly the equation will be y equals to -x. The third is same as the first. Since it is passing through -4 and parallel to x-axis, this is y equals to -4. And the fourth line is passing through -5 of abscissa and parallel to y-axis. Clearly, the equation is x equals to -5. I hope up to these questions is quite clear to you and the concepts of graph is also clear to you. All the points which lie on the graph is said to be the solution of the linear equation. And in reverse, if the solution, and in reverse, we can say every solution of a linear equation in two variable represent a point of the graph. With this, we end this video. Take care and thank you.